Hi guys. So you are going to work on your index card box project this weekend. So take out this worksheet and take out an index card. If you didn't take one, try to find one, or cut out a piece of paper in a 3x5 dimension shape rectangle. And what it says in the directions, I'm just going to follow on the worksheet and you can follow me here, is you're going to take your index card and you're going to turn it into a box, no lid, by cutting four squares from the corners, and then you're going to fold up the sides and tape them. So I kind of want to show you what that's going to look like. Now you have a diagram in the worksheet. It's this diagram right over here. Oops, right over here. And if you see how I labeled it, this is the 3-inch side, the 5-inch side, and then I labeled the corners, what I'm going to cut out. Half of them labeled X here. That's because I could change it if I wanted to cut out any size square I wanted to. They're all X by X, but you're going to go ahead and label those each 0.5. And then you're going to take your card and measure 0.5 or half an inch. So I'm going to go ahead and do that. So I'm going to go and here's my ruler. Here, you want to see? Here, look. Whoa. Okay, so I'm going to go ahead and label ½ inch this way and a ½ inch this way. And then I'm going to go ahead using my ruler. I'm going to cut out that little square right there. So I'm going to go ahead and cut that. My first time doing this, so I'm hoping you can see it. So I cut out, as you can see, right there, that corner. So now I'm going to tilt this back again so you can see me. Hi again. Okay, so I'm going to cut out this little square from each of the sides. Now you should measure it exactly. I'm going to just estimate it. So I kind of want to just show you real quick. So again, perfect, hopefully half by half, half by half, and half by half. Then what you're going to do is fold these. So you're going to fold this side up, and then this side, and then this side, and then this side. So that you have, again, mine's not perfect because I was trying to go fast for you so you could kind of see, but yours can be perfect. You'll have this cutesy little box. And you can tape all four corners. Now, like it says in your worksheet here, you're going to have to do all of these directions. You're going to label, and you're going to calculate and label the length of each segment. So again, if this one's 5 across, and you cut out a half from each side, that's a total of an inch, it's really now 4. And again, the same for the other side. Then you're going to calculate the volume of the box that would be formed. Physically calculate the volume of this thing. Then, if instead you cut 1-inch squares, that's why over here I made those X. You can change that now. Cut 1-inch squares from each side. Calculate the volume. And again, now down here is where you're going to change it to an X. So, what we want to do is graph an equation for the volume of the box. Basically, take what you did up here, and you're going to take that equation and you want to plug it into a graphing calculator and graph that. So I'm going to show you, review with you how to do that. So here's my TI-89. Again, find something online if you need it, like an online calculator or something like that. They have a bunch of the different apps that you can use. And you have to turn it on. And you're going to go into the equation editor. So that'll be Diamond, F1. And in your equation editor, you're going to type the volume equation that you got in number 4. Okay, if you're not sure, you'll see your packet says the directions for this are on the last page. So once you go ahead and type all of that into your equation editor, whatever you get here, you can type it in, hit enter, then you're going to hit the green button, Diamond, green button, and then F3, graph. Now make sure you pick a window that's going to be good to see your picture. Now remember, this is a box. You can't cut any negative sides. So when you look at your window, all your X's should be positive, so should all your Y's. So think about that and make sure you can see the whole thing. To change the window, window's in green right here. We went over that in class. Hit Diamond and F2 for the window. Now once you do all of that, turning your page to page 6, here's where you're going to do your calculus. So it says for you to take the derivative of your volume equation, the thing you got in number 4, multiply all that out, use the power rule to take the derivative, and then you're going to graph the derivative answer you get as y2 on your graphing calculator. So you go back into here, y2, and you're going to go ahead and type the derivative that you got. Now, it says explain the relationship between those two graphs. Talk about all the stuff we did with the first derivative and the second derivative. Talk about concave up, concave down, minimums, maximums. And then you're going to remove equation 1, and you're going to find the x value. So you have to find that minimum maximum thing. Talk about that. It's going to be a 0. We talked about how to find zeros in the graphing calculator. You go Google it if you need to. And then finally it says cut out your corners and make the box. You don't really have to make the box. Number 9 was like just for fun. This is what your box should look like though if you cut out the one that you actually do with the x value you get. You're going to get a final x value that will give you the biggest volume box. So it's not going to be, so you know, it's not going to be 1/2 by 1/2 and 1/2 by 1/2. It's going to be some decimal by some decimal that you'll have to measure, and then you can create the box. It'll just be something fun to do. So if you want another index card, you can again do a 3 by 5, or if you have an extra one and you actually want to make it, you could do that, and that's up to you. When you come to class next, we're going to go and do some other examples of how to minimize or maximize a quantity depending on what I give you. So I might want to minimize the amount of material that's used to create some type of container. Like we were talking about water bottles during the first week of school. How does that really work? Why are all water bottles shaped the same way? You want to minimize the material, but always have that, whatever it is, 16.9 fluid ounces. So again, when you come in next, we'll go over things like that. See you then. Bye.